Alright, welcome back everyone. My name is Chili and this is lesson 6 of the advanced programming tutorial series. Let me ask you a question. What do you think of when I say tick-tock? I'll tell you what I think of. I think of the Intel tick-tock rhythm of developing CPUs. Basically, they like to split the advancement of CPU technologies into two parts. There's the process part. That's about the actual manufacturing of the silicon and all the lithography and stuff that goes along with that. And then there's the architecture, and that's the developing of the actual circuits and the organization of the CPU's systems. So they split it up. They shrink the die, and then in the next CPU they work on upgrading the circuits, trying to make it more efficient and so forth. And that's kind of what we've been doing here in the advanced series. Not with die shrinking and architectures, but with the topics that we're teaching here. I've been going with math and then a little programming. We got that little rhythm going there. Oh yeah, good old water. So today's gonna be, well, not yesterday, but last lesson was a matrices. That was definitely a math topic. So today we're gonna do a programming topic. What I want to teach you, our next big goal, I guess, is gonna be collision, which is a physics thing. It's kind of mathy. But in order to get that, we need to be able to, we're going to need our ship, and we're going to need our map. So we have stuff to collide together. And so we're going to need systems and stuff like that. So that's what we're going to be doing this lesson. Ship, map, and drawing systems like the camera and all that happy bullshit. So let me get my new layer up here. We don't want that one. We want this one. Alright, so what are we going to do? Well, we have our, what did I call that thing? I don't even remember anymore. I called it it's not even in here. Polyclosed. There we go. So we've got our little object, polyclosed, and that is going to form the graphics that we draw on the screen for now. But we need a, well, first of all, we need a ship, and that ship is going to include the polyclosed, as well as information about like the position and the orientation, you know, the angle that we're rotated at, and all sorts of other bullshit that we'll get into, the speed of the ship, and so forth. So we need a ship to encapsulate all that stuff. And we're going to need a map. And it's also going to have a polyclosed. And what else? Well, we're going to need a camera and a viewport objects that we're going to use to transform our graphics from model space into screen space so that they can be drawn to our graphics object. But we're going to do it a little bit different than we did last time. Now, last time when we were doing it, you know, way back when we did this bullshit with the platformer, I believe we used functions to transform our coordinates. So we'd pass pixels or a coordinate to a function, and that function would call another function x prime y prime, and that function would call the graphics with x double prime y double prime. So in every step it would transform these parameters and then pass the parameters on. But we don't want to do that with this system. Oh no, that would be wasteful, because think about it. If we had to pass all the vertices and transform them all here, and then transform them all here, and we'd also have to transform them here too, by the way, because of the ship's position and stuff. That's not what we want to do, because we had this whole neat system where we could take our mate 3s and combine them all together with concatenation, and then just apply that once to our vertices. So we don't want to have to transform. We want to concatenate all these transformations together and transform at the end only once for every vertice. So in order to do that, we have to build up a matrix of transformation and pass that matrix along in a special way. Now what we could do, what I considered before, was just simply store that matrix in here and then have the camera and the viewport, you know, transform the matrix or concatenate, and then at the very end when we draw the ship we use this matrix. But in order to do that, we'd have to remember to reset this matrix after we've drawn at the end every time. And I don't know, I don't like that. It's a way to do it, but I have a different way we're going to do it. So let's see what we got here. I guess I better undo some stuff here. What we're going to do is we're going to create a new class. And that class is going to be a drawable. So we have a class here, drawable. And it's going to contain our matrix, which is going to be for our transformation. It's also going to contain a rect something. I don't know, rect F or rect I can't remember. And that's going to be for clipping. And what else is there going to be? There's going to be functions for, you know, concatenating the matrix and the clipping to the clip, the rectangle, whatever. But the main thing that there's going to be is there's going to be a function called Rasterize, and it's going to be virtual. And it's going to be a pure virtual function. And every object in the game that can be drawn to the screen through this pipeline is going to define a class. So ship will have, I don't know, ship drawable, and that's public drawable. Yeah. So it's going to inherit from this one here. And ship drawable is going to have it's going to have like a constant polyclosed reference. So it's going to have a reference to the model data for drawing, and it's going to implement the rasterize function. So the rasterize for ship drawable will be specialized for the data that it contains, and camera viewport, they'll have a function draw, and it'll take a drawable, of course. And so you can pass any drawable you want along to the draw here, and it'll be passed on to this draw, and every time it gets in here it's going to access functions to concatenate with the transformation matrix, and eventually we'll hit the graphics. I know this is like really complicated, But watch, I'll do it up in code with you guys. It'll be simple. And of course, map is going to have its own map drawable here. But we'll get to that later. So first thing is first. We're going to have to create this drawable system here. Alright. So let's get on with it. We're going to project, add new item, header file, drawable. This is kind of like an interface, except that it's not really an interface because it also has data. So I think of it as like a heavy interface. Pragma once. I don't know what to include. We'll include nothing to begin with. Class drawable. We're going to need matrix 3, that's for sure. Mate 3. There we go. Alright, so let's get our protected data, because we're going to be inheriting from this mother. So I guess being able to access the protected will be useful. So we need matrix 3, and we'll call that the transformation matrix. It's called trans. Get our trannies in there. And what is the other one? We're going to need a rectangle. Include rect. Alright, now here's where the problem comes in, because I'm not sure if it should be floating or integer. I'm gonna hedge that it should be integer. So we'll go recti. That'll be called clip. Alright, so we've got our clipping, our transformation. I think that is all we need for now. Now, public. So what's going to be part of the public matrix? Well, there's going to be a function called transform, and it's going to pass constant. We'll just call this one matrix. And that's the matrix to transform the current drawable object by. And we do that by going trans times and equals matrix. Now I'm wondering, because that could be a problem. Because think about it, the thing on the left is usually, yeah, that's awkward. I think what I want to do is I want trans equal to we'll have to look into that later. But like I said before, I've said this on the forums, the thing about matrix multiplication is that the positions of the operands is what's the important thing. So the left and right ordering is what is important, not the order in which the operations are necessarily completed in. Well, we're going to try this. And we're also going to do void clip const rect I. our clipping rect. Now we want to do clip dot clip to, and want to clip to our new clipping rect here. So this allows us to clip multiple clipping rectangles within each other, which can be useful. What else? Okay, now we also need rasterize. That's an important one. And that will take... Okay, so we have to include graphics in here. Or do we? We can just do a for declaration for graphics. So we'll go class d3d graphics constant gfx, and in here is constant equal to 0. So there's our virtual function. Why don't you like that? Pure specifiers only. Right, I didn't make it virtual. Fair enough, compiler, you win this round. Alright, so and this will be implemented by, you know, whoever actually makes a proper drawable. So we got clip, we've got transform, what else do we need? Well, we're going to need our we're going to need our constructor here. Trans will be mate3 identity, right? Because we have to start off with the matrix, identity matrix, and then we multiply other matrices onto that one. If we started off with zeros, anything times 0 is 0, and we could never concatenate our matrices. So when you're concatenating, start with identity. So we've got our identity. Now we need clipping. Now here we want to we can't start off with zeros, all zeros, because that would just be like everything is clipped, nothing is drawn. Give them nothing and take from them everything. That's not what we want to do here. What we want to do is we want to have the most inclusive clipping rectangle possible, and then we narrow it down from there. So the most inclusive would be, yeah, we're going to need to include, I think, float. I'm not sure. And then we do FLT underscore max. Right, okay. So right, float min? What's that? Okay. So we want to do, if it's top, bottom, left, right, we want to do negative float max. Let's just copy that. Bam. Off. I don't even know what button I hit there. So we want top, bottom, left, and right. So this will set us up with a transformation matrix, which does nothing, just keeps the same vertex that was input, and a clipping rectangle which clips nothing, keeps everything in the viewport. And that's what we want. Transform, clip, rasterize. I think that's all we need for our little, I don't know what you call this. Not a virtual class. Can't remember what it's called. Whatever, it doesn't matter. Now. Now we need another class. And this one is an actual proper interface. But I'm trying to think of where I want to put it. I think I'll just give it its own thing. We're going to get a lot of files here. I'm going to call this one draw target. Pragma once class draw target. So these are all of the objects that can be targets for drawing a drawable. Getting kind of tongue twistery there. So public virtual void draw. We have to include drawable here, and it's going to be not constant because we have to be able to mutate drawable by concatenating our transformation and so forth. So it can't be constant. Drawable, I don't know, we'll just call it object. Whatever, dude, doesn't matter. Constant equal to 0. There we go. And that's the only function that we have to implement for this interface. Now comes the fun part. D3D graphics is going to be a draw target. Is it going to be a draw target? Yeah, it's going to be a draw target. Include draw target. Public. There we go. Now what we want to do is because we're implementing draw target, we have to implement draw. So virtual void draw drawable object I'm wondering now about if I'm consting myself into a corner here. I sometimes do that. But this D3D graphics is going to be the end of the line for our drawing situation. We're going to go from here, and there's the end. And at graphics, we call rasterize. Rasterize right there. So, but I've got 4 declarations going, and I've got things referencing themselves kind of circularly. So we've got to tread lightly here. obj.rasterize this. Doesn't seem to like it. Wait, what? D3D graphics? That's wrong. Alright, let's see if fixing that will fix it. We're going to go down to drawable. do that. And that fixed it. Okay. So far, so good. But I have misgivings here. Because Rasterize is going to... yeah... If I make draw const, then I won't be able to change D3D graphics. But drawing will by definition change it because it's going to mess up with the buffers. So, this, I may have to give up the const on draw, unfortunately. As much as it pains me to do so, I don't think I'm going to be able to pull this one off. Because where is Rasterize? Let's go back to Drawable. Okay. What if I get rid of that? Yeah, see, he doesn't like it anymore because making this function const means I can't pass a non-constant reference. So I've got to get rid of this. And that means that I've got to go into my drawable and I've got to get rid of this. Ah well. Sometimes you can't const them all. You can't win them all. You can't const them all. But let's go back to where we were. So at the end of the line, draw is just going to rasterize the object. It's like, okay, you've got all your transformations done, time to put those pixels on the screen. And how to rasterize the object is left up to that object itself. All we do is we pass it a reference to the graphics and say, go nuts, do what you got to do, get those pixels on the screen. So that's D3D graphics set up, I think. Now we've got to do our camera and our other thing, viewport. So how are we going to manage that? Camera and viewport. Drawable. Draw target. Yep. Okay, so we want to go project, add new item. Let's start with the viewport, I guess. Alright, pragma once. What are we gonna do here? We need pound sign include draw target class camera public draw target private, and it's gonna also have a reference to draw to the next draw target in the chain, right? And 1 second, let me check something out here. Something is bothering me. Alright, the thing that was bothering me actually fine, but I found some other things that I fucked up. But we'll get to that later. Let's work on camera first. Okay, so camera, it has a reference to the next item in the chain. it also has a, I guess I'm gonna need vec2s, eh? Include so it's got a vec2 for the position. The camera can also have rotation and zoom, but I guess we'll add that later. For now, the camera can only pan, and that's good enough for us. Oh, and we need a vec2. This is a vector that goes from the current position of the camera to the center of the camera view. Because remember, we like to work with our camera as if its coordinate equals its center, but in actuality, its coordinate equals its top left corner. You know, stuff, bullshit. Let's implement our draw function. So I believe that is virtual void draw. Const drawable. That's not right. Wait, where's draw target? Let's go to definition. Yeah, not constant. Draw drawable object. Wait, this one's also. Yeah, it makes sense. I just love the consts. I don't know why. Okay, so drawing an object means going object dot transform mate 3, and we want a translation, and we want to translate by how much? That's a good question, actually. Because we have to take into consideration the center thing here. So I'm just going to cheat and look at my old code instead of thinking. Because thinking is hard. Where is my transform? Wait, that's wrong. I want to go to camera. And transform is just negative position. I guess that makes sense. We have to take into consideration the center when we're doing our translation, only when we're interfacing with the user. So we go negative position. And then we pass it along the next dot draw object. So we add our contribution of a translation and then we pass it down the chain. And that is it. Now move to void vec2 position, not const. So this is going to move the camera to a position, but it's going to move the center of the camera to that position. So we want position. Oh, that's dumb. New position. We want position equal to what? New position minus to center. Is it going to be minus or is it going to be plus? It's going to be minus. How do I know this? Well, let me show you. I need a new layer. Yeah. So let's say the user, the position that we want to go to is at 400, 300. Now the vector, here's our screen, or our viewport size. It's 800 by 600. So the vector to center is going to be 400, 300. So if we subtract that from this, our screen corner is going to be 0, 0. And that means that our screen is going to be positioned such that the target is going to be in the center of the screen, or the center of the viewport. So that means that subtracting is the proper way to go here. You just do a little mental experiment and see if your intuition was actually true. Works a lot of the time, I think. So move to, that's fine. What else? I could have sworn there were other functions that we wanted for our camera. Move to, I'll zoom, we can do that later. The destructor is not necessary. So we need our camera constructor here. Camera. That's not what I wanted. I'm just going to copy and paste this here. I've got code. Why not use it? Okay, so draw target next. Because it doesn't have to be a viewport. The next thing in the chain could be something else. But it's usually going to be a viewport. I'm not going to lie to you. So next is next. Now the camera will always be positioned at 0, 0 to begin with. Just for shits and giggles, I guess. Now our to center vector is going to be half the width, half the height. So that's fine. And zoom is not a thing yet, so we'll just get rid of that. And there, my friends, is our camera class. All done up. Ready for the ball. Let's add a new class. And predictably, it's going to be the viewport. Add that motherfucker. Wait, what? Viewport already exists in the project. Oh! Okay, I see what I did. I fucked it up. I said I was going to do viewport, and then I proceeded to make the camera. I want to rename this. How do I rename it? I guess I gotta save it and close that. And we'll call that camera. Open it back up. There we go. Okay, now we can make a viewport, hopefully. All we gotta do is add new item. Alright, we're gonna go to camera. I'm gonna copy it. Viewport, paste that shit. Because a lot of it is gonna be the same. Draw target next. That's fine. Position is not good. What we want is we want a rect eye for the clipping rect. And I think that is it for data. Now to draw, we need a translation. This is going to be interesting. We need clip dot left dot top. No, dot left. And we need that in the positive because we're offsetting by however much the viewport is offset relative to the screen. So we need clip dot left, clip dot top. But we need those to be floats. There we go. Now that should work. Yeah, it's working. Okay. So we want to translate by that much. Then we want to clip it. Clip by the clipping rectangle. So we slide our object over with a little translation, and then we clip that object, and then we draw the next one in the chain, which will usually be the D3D graphics. Now we don't need move. We gotta change this to viewport. And rect eye for the rectangle. Draw target next. Whatever. So we go next, and clip is rect. That should be fine and dandy. Let's add a couple of functions here. We'll do int get width, and that'll just be clip dot. Interesting. A rectangle does not have a get width, get height. I'm going to add that in. Let's go to rect, because I think that would be a useful function. Let's outline, collapse to definitions. That's good. So inline int. No, wait. It's got to be inline t get width constant return right minus left, and we'll just copy that. Whenever I come across a thing where I'm like, that could be a useful function, I like to add it into the base class, like I'm doing right now. Bottom minus top, and this will be get height. There we go. Useful little functions that can come in handy. Now we go back, where am I? There we go. So get width is return clip dot get width. And get height const return clip dot get height. There we go. Okay. So that will be our viewport all set up, I think. Now we need to actually implement Drawable for our what? Polyclosed here. So we're gonna go. There was a thing I was gonna do here. Wait a second, let me think here. Alright, so that thing I wanted to do, that is not going to be a thing. It's going to be too complicated, but I did remember that there was a thing I had to fix. So let's do that now. I think that was in Drawable. And if we go in here, we see that we're setting it to float max, but it is a integer. So that would be pretty stupid and possibly par for the course, but still. Let's copy that. Now I don't think we need float anymore. So we'll get rid of that, and that is all she wrote. I did have another constructor that I defined in here. Where is it? Drawable. I think I put in D3D graphics. Yeah, in my little test thing, I just lump classes together and like a whole bunch of bullshit. Here I've got a copy constructor, but I think that's just a default. I don't think I actually have to define this. This is defined for you by default. So I'm gonna say, yeah, this is fine. This is fine the way it is. Now let's go back all the way to the year, whatever it was. No. I don't understand how this back thing works. It takes me to weird places a lot of the time. Places that I haven't been in a while, and it's like, why are you taking me back there? What is going through your head? Let's make a class. Now we're going to make the drawable class that this polyclose is going to poop out when we want to draw it. So we're going to call this one, I don't know if I can do this, but I want to call it drawable. Public drawable. Can I do that? No. So obviously it's not going to be good. What I want to do is, well, first of all, I have to include drawable. That didn't fix it, did it? What if I did this? Yeah, that works. Yeah, if you put a scope operator before before some kind of identifier, what that says is I want the global one. I don't want the local one. I don't want the one that's inside, for example, if you're using namespace blah blah blah. I don't want that one. I want the one that's outside of all the namespaces and outside of the class. So this says I want a drawable in here that is based on the drawable that is outside in here. And I can do that. Otherwise, I'd have to rename this one to like iDrawable or something, which is dumb because I don't use that notation for any of my other interface classes. So, yeah, I like this solution. I like it a lot. Let's do it. And let's also what did I do for this in my my ding-a-ling, everybody's thing? Okay, so I see. I made references to the stuff. I could do that. Don't get me wrong. I don't mind it, but I'm thinking all I need is a reference to the base class. So we'll go const poly closed and I could call it base, but it's not really a base. I call it parent. I'll call it parent. That's a good name. It's a good name as any, because you see, here's the thing, because this is an internal class, it has access to all the private members of its enclosing class. So just with this one reference, I can reference anything I want in there. And I like that for now. I mean, I could make the references so that it could only reference individual parts and then have to initialize those references in the constructor, and that would work, but I don't see the need to hide things. I just give it access to everything. constant access, mind you. Not allowed to change anything, just read it. Okay, so Drawable needs const poly closed parent parent. There. I don't know why it does that. So that's the constructor, very simple. Just initialize the reference to the parent. Now, we have to implement the pure virtual function in Drawable, which if you remember is Rasterize. So we go virtual. You don't have to write virtual, but I like to. Void Rasterize. And this one is going to be class, because I can't remember if we actually, yeah, we do include D3D graphics in here. So I'm just going to go D3D graphics ampersand GFX const maybe? Yeah. Pretty sure it was const. And yeah, and then we just basically do what we did for draw, but we put it in here. So we go auto I is equal to parent.vertices.begin. Just put parent in front of all this stuff here. Copy. End is equal to parent.vertices.end as long as I is less than n, I++. That's good. Parent.color. Parent.vertices.back. Front. We'll put that there. Keep it all on the screen. Keep it on the screen, people. V. And I think we're done. That should be it for the rasterize. So now we don't need draw in here anymore because you can't draw this class. Only closed. There we go. This one doesn't need anything. Poly closed. Okay. But we do need a function in here to get the actual drawable. So we go drawable. No. We go, yeah. We go drawable. Get drawable. Const. Return drawable this. Now remember, because we're inside the scope of this class, it's going to be this drawable, not this drawable. Why are you fucking with me? Error. Declare that line 37 is inaccessible. That was dumb. Private. I don't know if that's a word, but I think it should be. Public. There we go. How do you like that now? Much better. Okay. Alright, so now we got our get drawable thing. Now we're going to put it all together and see that it totally doesn't work. Because we just coded up a bunch of bullshit. And usually when you code up a bunch of bullshit and then you try putting it all together, it don't work. This is my experience of the world. Okay. Yes. So what we're going to do here is we're going to add we're going to add my little friend. His name is, well, first of all, we gotta include that bullshit. So include camera, include viewport, viewport. There. I typed it in all by myself. So camera, cam, viewport, port, model, angle, scale, that seems fine. Alright, now we go into game.cpp because we need to do stuff. Okay, so viewport, okay, port, needs somebody to love. No, needs graphics and needs a rectangle. Okay, now I can't remember the exact dimensions of this rectangle, so I'm going to cheat and look at my prototype, which is in here. Alright, so yeah, it's just 0 and then screen height -1. So we gotta, yeah, okay, it's exclusive or inclusive? It is inclusive. It includes the final pixel in there. So that's top, bottom, which is D3D graphics, screen height -1, and then left and D3D graphics, screen width -1. How's that? Looking good? Okay, next. Camera. And this one wants width and height. So we're going to do... We're going to do port. And then we're going to do port dot get width and port dot get height. And I've done something here that will fuck us up. And if you can see what it is, then you get a gold star. You get the goldest of gold stars, but I don't think you can see it. So I'm just going to tell you. The thing I fucked up is here I go port. I initialize my port, and then I use port to initialize camera. Except that that's not actually the order in which they're going to be initialized, because the order of initialization of class members is dictated. I said dictated by the order in here. And this order is backwards. Oh, I fucked it up. How did I do it? Control X, Control V. There we go. So we want viewport first so that that gets initialized, and then we can use the width and height to initialize the camera. Then good things will follow. Good. Okay, so yeah. That can be a tricky error that can always get you. The solution to never getting tricked up by that error is don't use initializer items to initialize other initializer items, but I love doing that. I love that shit. I love my initializer list here. It's so good. So now we've fixed this. Now model.draw is no longer a thing, so we can't use it. We cannot use it. So what are we going to do? What is a boy to do? Well, what we do is we go model. We go poly closed. This will actually get better once I do some more stuff, but we'll go poly closed drawable. We create a drawable. D is equal to model dot get drawable. There we go. And then my friends, we I guess we can do d dot transform and we want to rotate it, so we'll go matrix 3 rotation angle, and we also want to scale. We also want to do the other thing. We want to do this, that, and the other, which is translation. And we'll just copy this because I don't want to type all that bullshit out. No, fuck you. Thank you. Fuck you. Yeah, and we'll multiply that. So we'll do translation, rotation, and we'll forget about scaling for now. Fuck scaling, man. Scaling is dumb. I will scale it. I'm feeling generous. I don't know how generosity plays into that, but scale. And then, after we've transformed our drawable, we'll go camera dot draw D. Now this looks like more work, but trust me, it's gonna be good. You gotta trust me on this one, friend. Build solution. Well, it didn't barf anyways. I really want to get rid of this. Just because I don't like having warnings in my build thing. How do I... Pragma Visual Studio warnings. Apply the given level to the specified warnings. Pragma warning. Disable. Once. Only one time. Suppress. Pragma warning. Disable. Hehe. Because I don't actually want to change the code. I like it the way it is, but I just don't want this fucking warning. 4996. And then Pragma warning default. Okay, this should work. Build this motherfucker. No! No, why did I get more? Why did I get more errors? Why do you do this to me? Okay, because I had to rebuild stuff that wasn't built before, right? Oh, man. Dude, I don't want to deal with all this bullshit. Okay, so this is obviously not going to be enough. I'm going to use Pragma push pop. Except I'm not really good at Pragma warning push. Warning disable, disable, disable. Some code pop. Interesting. So I do push, then I disable my things, then I pop at the end when I want to restore. That's what I'm going to do. That's how we do. No. Okay, so we do Pragma warning push, Pragma warning disable 4996. And then I pop it at the end. Ah, oh, too long. Scroll. Yeah, there we go. That will take care of this. But there's a problem, and that is that the header file is included in other shit. So what I'm going to do is I'm going to go to that freaking header file. Where is it? Build. I'm going to rebuild the whole solution. Now I'm going to go here. DLDL writer ASCII. Here we go. Okay, here we go. I'm also going to push this one in here and pop it when we're done. Pop and lock. And also copy. sprintf. fu sprintf. Pragma warning pop. I'm wasting a lot of time on this, but I feel like it's worth it to soothe my OCD. Push Pragma warning pop. I could have just pushed and popped at the beginning of this file too, but I am going to rebuild all now. Oh, argument conversion from int to float, loss of data. Where is it? Int to float. Ah, this one. Okay. Float. Build. Oh, look at that. I'm going to rebuild all just to see the clean build. No warnings whatsoever. There we go. OCD has been appeased. Next, we're going to see if this actually works, because I think it might not. It's actually working pretty good. It's working like a charm. Interesting. And the zooming works as well. Alright, that's good. Okay, so ostensibly this means that our camera system is working. We won't actually be able to tell until we start scrolling. But we have a thing, and it is good. Next, we need to create a ship class. I have a feeling like this is going to be a long lesson. You might want to break this one up, kids, into multiple parts to make the download faster. What am I going to do?